Now we're going to look at temperature, and there's really three different measures of temperature. We have Fahrenheit, Celsius, and Kelvin. I'm sure you're all very familiar with Fahrenheit. That's the unit of measure that we use in the United States. But a lot of the world uses Celsius. Celsius is probably the most common. Some people call it centigrade, but it's the same thing. Celsius is most commonly used. And Kelvin is more of something that scientists tend to use because negative temperatures don't make a whole lot of sense because temperature really is a measure of the amount of vibration of molecules and the heat that an object has. And so negative heat isn't really it's kind of a weird way to represent that. So they move the scale basically and create no negative temperatures with Kelvin, with a Kelvin scale. So we'll talk a little bit more about each one. So let's focus in on Fahrenheit for a moment. This was probably the first one, I believe, that was created, and basically the guy, last name was Fahrenheit, who created this. He basically said at the time he thought that, and I'm kind of going by what the historical stuff that's in the book, so you can read up on this a little bit if you want, but basically thought that water with salt was one of the coldest things. Getting that to freeze was one of the coldest things you could get. It was as cold as you could get. And so he called that 0 degrees Fahrenheit. And he thought the human body had an average temperature about 96 degrees, which he was wrong about. It's actually 98.6, but he used 96 and cut the difference there into 96 equal pieces, called them each a degree Fahrenheit, and that was the establishment of that system. In that system, water without salt freezes at 32 degrees Fahrenheit. This is really a key. Let's circle that one. That one's a key measurement, the actual freezing point of water. And water boils at 212 degrees Fahrenheit. That's also very, very important. In all of these, you'll see water freezing and boiling. And those two spots are going to be very important comparisons. Okay. So then the Celsius scale was developed. Basically, they said, well, why have all these weird numbers in here? Why don't we just say water freezes at 0 and boils at 100? Right? Metric system always deals with powers of 10, right? And so this was kind of a nice one. Just go 0 to 100, cut it up into 100 equal pieces, and that's your Celsius scale. And that works out very nicely, actually. So again, water freezing and water boiling. Same here, water freezing at 32. So 32 degrees Fahrenheit is equivalent to 0 degrees Celsius, and 212 degrees Fahrenheit is equivalent to 100 degrees Celsius. That combination of points allows us to form a relationship between the two, where you can convert from any Fahrenheit to any Celsius and from any Celsius to any Fahrenheit. Basically, the way you do that, and I'm not going to go through all the details because it's kind of beyond what we've done in this course, but you may have learned in some algebra courses that you can find, between any 2 points, you can find the equation of the line through those 2 points. Well, if I take 2 points, and the points being 32 comma 0, right? 32 and 0, that's the freezing point of water, and 212 comma 100, that's the boiling point of water, and I create using the slope formula and the slope-intercept formula, which we haven't studied and won't study, but it's a very interesting algebra process. You can come up with the equation of the line that connects the 2 points, and that gives us our conversion for any point or any degree Fahrenheit to Celsius or Celsius to Fahrenheit. And the conversion there, if you were to do that, is a Fahrenheit temperature ends up being equal to 9/5 of a Celsius temperature plus 32. Okay, it's actually the slope-intercept form of a line when you do that conversion. Okay. if you were to solve this equation for C, if you were you'd have to subtract the 32 from both sides and multiply by the reciprocal of the 9/5, which is 5/9. You end up with Celsius equaling 5/9 times the quantity C minus 32. F minus 32. There it is, F minus 32. And so that's just a solution of the other equation for C. These two formulas are nice conversions. So if I know the Fahrenheit temperature, I plug it in here, and I can get the Celsius temperature. And if I know the Celsius, I plug it in here, and I get the Fahrenheit temperature. So two very nice formulas. Of course, they look a little bit weird, but they're doable. So as an example, if I wanted to, let's say I wanted to convert the salt water freezing point, which is 0 degrees Fahrenheit, into Celsius. Let's see what that translates to on the Celsius side, right? Well, I know that it's 0 degrees F, so I need to go to this second formula, plug in a 0 for F. C would equal, right, if F equals 0, then C is 5/9 of 0 minus 32. 0 minus 32 is negative 32. You're just using the order of operations to evaluate that. 5/9 of negative 32. Now, that doesn't come out evenly because 9 doesn't go into 32, but we have a calculator that will help us out. And, wait a minute. Oh, I did that wrong. There. It's around 17 7/9. So it's approximately, if I round it off, negative 17.8 degrees Celsius. Okay. So the freezing point of water with salt is negative 17.8 degrees on the Celsius scale. Okay, it's 0 on the Fahrenheit scale. Now let's say you were over in Canada or something, and Canada uses the Celsius scale, and there's you look at the weather. You're over there for a few days, and the weather says it's going to be 40 degrees Celsius. You're like, does that mean I need shorts and a t-shirt or jeans and a hoodie? I don't know. What did I say? 40 degrees? I think I said 40 degrees. Let's say you wanted 40 degrees Celsius, so C is equal to 40. Well, that conversion is done by plugging the 40 in for C in this equation, solving for Fahrenheit, and then at least you get an idea of how warm it's going to be in the terms that we understand, right? So that's going to be F is 9/5 times 40 plus 32. Well, 9/5 of 40. Well, 40 over 5 is 8 times 9 is 72. Good grief. 72 plus 32. I think you're wearing shorts. That's 104 degrees. Does that make sense? Let me double check on that. Yeah, that's about right. 104 degrees. I'd be okay with that. Well, I'm not okay with that. I'm okay with the calculation. Yeah, that's pretty hot. So anyway, so 40 degrees Celsius, I don't know that Canada typically gets that hot, right? I was in New Mexico this summer, and it was 107 degrees when we were at White Sands National Park. That was scorching. But I don't see Canada usually getting that high, so that would be an anomaly, right? 40 degrees. So anyway, kind of some neat conversions here, and of course you're just plugging numbers in, calculating the output. Now the Kelvin is interesting because it just basically slides the Celsius scale so that 0 is no longer at the freezing point of water. It ends up being the point at which no molecules move at all. Okay, it's the coldest possible temperature because heat is a measure of the moving of molecules within an object, and the faster the molecules are moving and bouncing around, the hotter the object is. The more heat it has, heat energy. Thermal energy maybe is a better term there. But anyway, so Kelvin is where all molecules cease. They're all frozen in place. They're not vibrating or bouncing around at all. And you can't get any colder than that because you can't get things to move less than nothing. Right? Yeah, makes sense. So anyway, less than nothing. Anyway, so in that case, water freezes at 273.15 Kelvin. Now, what's weird is we don't use the degree symbol. We do use degree symbols for Fahrenheit and Celsius, but not with Kelvin. Can't tell you why, but we don't. We just use a big K for the unit there. And so basically, if you just slide the scale, keep the divisions the same, but just slide it down to the appropriate value, 0 is where molecules cease, 273.15 is where water freezes, and 373.15 is where water boils. Okay, so it's just 100 degrees more, right? 100 degrees more, 100 degrees more there, 100 degrees more there. So the relationship is really a one-to-one kind of relationship. In other words, the scale is the same, you're just shifting it down. The separation between degrees is the same, I should say, between these two. You're just shifting the starting point. And so the conversion formulas for Celsius to Kelvin and Kelvin to Celsius, we have K is equal to C plus 273.15, and C is equal to K minus 273.15. Okay, so those aren't too bad. All you have to do is either add or subtract to get to the other one. And if you needed to go from Fahrenheit to Kelvin, you just have to go through Celsius to do that, right? You figure out the Celsius and then you figure out the Kelvin, or going the other way around, you have to go through Celsius. That's the easiest one to do. There exists a conversion that goes directly from Fahrenheit to Kelvin. That's kind of an interesting idea. I could do that in another class. Not here, but just thought of something else for another class. Okay, anyway, but this works. This works here. So if you wanted to find out, for instance, what that 40 degrees was, right? The 40 Celsius in Kelvin is. If you want C to be 40, then the Kelvin temperature that corresponds to that is just 40 plus 273.15, which is simply, what's that? 313.15, right? 40 degrees more than 273.15. And so if you had the Kelvin temperature, you want to find the Celsius, you subtract instead of add. So, but the same value, 273.15 on those. Okay, so just kind of a cool conversion. These formulas are really useful. And so you're going to be using these, quite a bit here. The 4 formulas. And of course, really all you need is 2 of them. If you knew 2 of them, you could solve for the other 2. Not too terribly there. So anyway, cool stuff, cool conversions. 3 different measures of temperature, which is a little bit confusing. It's nice to have one that we're really accustomed to, but of course, as soon as you travel or traveling, you're going to be seeing Celsius, so you've got to know how to get back to Fahrenheit. And if you're doing some science experiments, well, maybe Kelvin is the way to go. It might be more useful to you. So anyway, good stuff.